Okay, to start off lesson 6, what we're going to do here is we're just going to actually work a sample problem that you would see in lesson 5. It pretty much looks the same, starts the same, but what we're going to show you here in this particular problem is that even though you're going to use the rational root theorem, when you pull the linear factor out of the cubic, your remaining quadratic may not be factorable, which would lead us to completing the square quadratic formula. This may lead us potentially to irrational roots or complex roots, and so that's what the context of this particular lesson is all about. So what I would like you to do is, for sample problem 1, go ahead and work it on your own and come back and see the solution, and just start this problem the way you would have done a problem in lesson 5. So go ahead and work that at this time. Okay, so I'm going to go ahead and start this problem. Now, first of all, notice it says find all the roots or zeros for the given polynomial. If you recall, that's just the same thing as if the cubic were equal to 0. And so we just like as if we were solving this. So really all we're doing is looking for all the x values or all the potential roots of this particular cubic. So let's go ahead and find our p's and q's for this particular problem. And now that we found the p's and q's, we'll find all the possible rational roots of p over q. Okay, and as you can see, there are a very large amount of possible rational roots for this particular cubic. So what we're going to allow you to do, since we're just learning this information, is use your calculator to get a good visual on the potential zeros and see what that's going to look like and see if you can narrow that down. Now, as I look at my calculator, I'm going to actually use the 2/3 root. So let's go ahead and set up the synthetic division for that. And as you can see here, we get a 0, which is what we were looking for. And our depressed polynomial in this case is 3x squared minus 6x minus 12. So let's go ahead and go and factor this particular polynomial and see if we can break this down a little farther. So here we are, we've pulled out our linear factor and we have a quadratic. You can see that there's a common 3 in here, and I'm going to go ahead and pull that 3 out and distribute it to the x minus 2/3. So basically what we did here is we pulled out the 3 from there, and then I went ahead and distributed it to that part over there. It's kind of an unnecessary step, but it gives us a better view of this x squared minus 2x minus 4. Now you should notice that that is unfactorable. And so we would have a linear part and a quadratic part that we need to solve. So the simple part is this. 3x minus 2 equals 0. We know that the x equals to 2/3, and we had that with our synthetic division. However, the x squared minus 2x minus 4, this requires completing the square quadratic formula. I'm going to go ahead and use completing the square here because I have a leading coefficient of 1 and an even b term. Okay, and so what you can see here is that x equals 1 plus or minus the square root of 5 gives us 2 irrational roots along with our rational root. Now all 3 of these roots are real numbers, so that should be pretty straightforward for us right now. But what's important is that when you break out the linear factor, do you recognize how to deal with the remaining quadratic? So that's some of the newer information that we're going to deal with in this particular lesson. What I'd like you to do right now is go ahead and work sample problem number 2 if you haven't already, and come back in the next video and watch the end result of that.